Thank you for joining us today for SolarWinds 5 Business Insights to Gain from APM. I'm Dave Wagner, and I'll be doing the presentation today. Doing our demonstration will be Pete DiStefano. Like to get started here. If you have any questions at any time, please feel free to put them into the Q&A window in your WebEx application, and we will have a section at the end where we'll be happy to answer them for you. Thank you. And with that, let's begin. So our agenda today, I'll talk a little bit about the very current business and technical realities that relate to application performance management. I'll talk a little bit about what it is, why it is, who uses it, why they care, what's really driving it. But the meat of the content today will really focus in on some critical business insights that you can use when thinking about APM and its applicability to those business and technical realities that more and more companies are currently facing. After that, I'll briefly cover the SolarWinds APM Suite for our solution. We'll do a demonstration and have a Q&A. So that's our agenda today. Hopefully you will find it valuable. And again, please, whenever you have a question, feel free to put it in the Q&A chat window, and we will get to those at the very end. Thank you very much. So let's take a step back and look at the business realities. These realities have been driving the ever-increasing adoption of APM for the last several years, but this year's pandemic has and its economic ripple effects across business, across technology, across supply chains, and the rest really has done nothing more than crank that knob up to 11, as the old movie Spinal Tap used to talk about. It's accelerating it even faster than it was already accelerating. The business driver behind all of this is business digitalization, the digital transformation of companies' business models at all levels, both physical and electronic, toward being online, real-time transaction processing systems. Basically, it's the implementation of ever more business processes associated with ever more business product or service lines in custom applications in the hybrid and public cloud. Now, this is important to note for most companies, the ones who did not start in the modern technology era of the last 4 or 5 years of services and microservices, containers, cloud apps, and modern computing languages. This reality is basically added on top of existing hybrid commercial application environments. And we'll talk a little bit about some of the additional complexities that happen there and why that also drives APM. But these things together are the business driver behind adoption of APM. Now, business basically measures success of these transformation efforts by the performance of the customer. Now, I use the term customer in both the B2B or B2C sense, basically the speed of the transactional relationship between the company and the downstream constituents, whomever they might be, whether it be process automation or funds transfer or online banking or online shopping. It's all the same from that perspective. Those critical success factors are really simple in the fact that there's really only 3. Everything must be up. In other words, they can't have it not available when they're going to do it. Everything must perform quickly so that it isn't too slow. And everything must be cost effective. Those are the 3 levers that business leaders looking at optimizing profit and loss and growing revenue and market share are always looking at. Now, of course, as always with technology, the devil is in the technical challenges associated with accomplishing that. And first and fundamentally, those technical challenges relate to the complexity. The complexity has basically been amplified in multiple dimensions, and we'll talk about that in a moment. But basically, it's making it much more difficult to determine why things aren't up when things are broken, and to determine why things are slow. And again, these are the things that are impacting the need for APM and what APM needs to be in order to solve it. So basically, the challenge in a nutshell is how do you monitor, optimize, and fix quickly in a constantly changing environment. So I mentioned complexity. So what actually is really different with custom web apps and SaaS versus more traditional methods of deployment, hybrid environments, private cloud, monolithic apps, and the like? Well, first and foremost, across the entire stack, and when I say stack, I mean everything from application architecture, shown here at the top, all the way down to the ultimate deployment model, whether it's your private cloud, hybrid cloud, public cloud, has multiple levels in that stack. You've got changes from old monolithic applications through service-oriented architectures and into today's microservices-based. You've got new ways of rolling everything out from development into production. Classic Waterfall has moved over toward now today where many companies are implementing in a CI/CD, continuous implementation, continuous delivery. Those apps themselves are written in multiple different languages now. It used to be just a few short years ago, it was Java running in a virtual machine, running on a physical host. Now you've got multiple other new languages that are fit for purpose for other things as well. You've got Node.js, Python, Go, Scala, PHP, .NET, and others. And then the actual packaging of these for deployment and ongoing operational management. You've got multiple different services, multiple different containers. You've got Docker, Kubernetes, Red Hat's OpenShift, now acquired by IBM, Pivotal Cloud Foundry acquired by VMware. So you've got lots of different, if you will, platform environments. You've got a proliferation of the way the data itself, the data of record, if you will, is being structured and stored. It's no longer just SQL databases. It's non-SQL databases, cloud databases, and the like. And then, of course, everything's been virtualized. Now, when you consider the fact that all of these are multiple different new things and that they are all dynamic and changing all the time at different change rates, you can understand the complexity of the total stack with respect to how do you monitor, manage, and optimize it. So at a high level, what is APM? In a nutshell, very simply, think of it as an umbrella term that basically covers the monitoring and the management of the entire lifecycle performance of software applications. So from the moment they are being coded in dev, whether you're a full-on DevOps process, CI/CD organization or not, from the moment they're being coded until the moment that they are deployed in production, and then from that moment in production throughout the lifecycle, the operational lifecycle of those applications, it's the umbrella term that covers monitoring and managing those from a perspective of performance. So, and this is not an inclusive list. This is just meant for example. But basically, this can include everything from code-level diagnostics, so the person writing the code can know how efficient it's going to be, to identifying slow transactions, pre-production or post-production, all the way out to measuring end-user satisfaction. How is the transactions themselves actually performing at that B2C or B2B interface outside of your company? So that's what APM is. It's an umbrella term. And by the way, it keeps changing over time. Not all that long ago, APM was solely reserved for development tools that help people optimize the code they're writing. It's been evolving over the last few years to include ever more pieces of management and monitoring technology. So let's talk about the use cases. And I'm breaking them here into really two major buckets, if you will. There's the use cases associated with the development portion of the life cycle that I mentioned before. So while the code is actually being written. And these use cases really fall into three major elements. One is everything associated with monitoring the performance of the application and the infrastructure and their interrelationship together, both from that single app's perspective as well as from the perspective of any and all other users and consumers of that infrastructure resource. Basically there, the use is straightforward. It's while you're testing and optimizing the application code's performance and efficiency. And to do that, you use code profiling and tracing. We'll show you some of that in the demos later on. The use case workflow really is about speeding the troubleshooting of those performance problems across all the infrastructure and all the application code, so that by the time you go live in your DevOps process or in your production rollout, you know that that application is as efficient as it possibly can be and that all the associated infrastructure is configured appropriately. While you're doing that in development, you also need to factor in any and all events and errors associated with all the applications, services, and infrastructure elements. And to do that, you need to be able to bring in those log entries and events into a centralized place for analysis. The use case there in dev is straightforward. It assists the developers in building apps that work and finding errors and fixing them more quickly. From a user experience perspective, you need to factor in what does that performance look like from, again, that external view while you're in development. So you can use synthetic transactions there to identify bottlenecks, get real-time insight, and speed up your web application while you're in development. So that's the dev portion. Ops is very similar but slightly nuanced and different. Ops is really about real-time problem identification all the way from the client side to the server side. And I use server side to describe everything that's not client side. So don't think of that as a physical server in a dedicated data center. It's all about doing that as quickly as possible to optimize your MTTR, mean time to repair, if and when issues do occur in production. At the application and infrastructure monitoring section, it's basically, again, about speeding that troubleshooting. But again, the use case is we've got something that happened or is about to happen, and we need to be on top of it as quickly as possible. And so there you need to monitor, manage, and optimize the performance and infrastructural capacity needs so that you make sure you've got sufficient resource needs to meet demand as it changes. In production, log and event management is exactly the same use case. It's about bringing together all those events into one place where they can be aggregated, analyzed, correlated, tied to application performance traces. We'll talk about that and the like. Again, to speed that troubleshooting and use case troubleshooting across your application and infrastructure. User experience is slightly different. Now you actually need, in addition to synthetics to get inside the transactions, you actually need to understand how the real user performance is being experienced as it varies, for example, across geographies or across systems that the users are interacting with based on potentially transactional routing rules and the like. So user experience, again, it's about understanding how they are performing, but again, in the operational use case. So some additional factors to consider. The cost of bugs, the cost of bad code continues to grow. This has been true for quite a while. There's been dozens or hundreds of pieces of research on this, and they all point to the same thing. That is the cost to fix an error. The total cost to fix an error is 10, 100, in some cases 1,000 times more expensive than fixing it and preventing it before it got shipped and turned live in production after you shift from dev to ops. It can, in some cases, cause billion-dollar losses. I found a blog written just last week by a technical training services company, Edureka, and basically, if you go there, and we will share this link, but they go in there and they actually show that there's this literally 100-fold increase between when you're in dev versus when you're in full-on ops in terms of cost and time spent. Gartner's research, and this was true in 2016, it's only been getting more true ever since, is that cost of downtime is extremely high, and literally every minute when something's down, you're bleeding money. Bugs cost a lot of money, so get them early in the life cycle. So now let's talk about some insights that you can gain with a modern APM solution here, and some of them are not necessarily obvious. Hopefully you'll find these extremely insightful and valuable as you look at your monitoring and management of your application and infrastructure environment. So first and foremost, timing isn't everything, it's the only thing. I like to say that in 2020, where so many people now globally are in a work-from-home environment, which has its own pros and cons. It has its own efficiencies and inefficiencies. But the reality is across the board, B2B, B2C, work-from-home employees, slow is basically the new down. So I just wanted to walk into kind of the history of why this has become and then really take it to the next level. So if you think about not very long ago, virtually all businesses operated on an analog model. Transactions were physical entities, right? Customers, whether it's you or a B2B customer, would go to a retailer or a supplier, or you would contract them to place an order. Businesses would contract with each other to do things such as ordering a part. When products were in stock in sufficient quantities, then they'd get shipped and then ultimately delivered. Most companies were using packaged applications that were oriented around these kinds of traditional supply chains. So they'd have a packaged app like inventory management or scheduling or manufacturing automation systems, things like that. These were deployed on large and dedicated, typically, IT infrastructures, carefully configured, managed for the utmost in reliability. And so at that point, companies' competitive differentiation was all about product, the quality, the cost, and of course the company's brand. Now, these systems were highly reliable, but they were extremely time-consuming to initially bring to market. And due to the challenges with capacity optimization costs were also quite high, because after all, these were not shared resources, and they had to be provisioned for peak demand, leading to lots of wasted money, if you will. Now, of course, that was set the stage for the digital transformation that's only accelerating in the last 3 or 4 years. But let me give you an example, and this example is literally as of just a couple of months ago. My son is a commercial on-demand cargo pilot. Wonder if we have any cargo dogs out in the audience here. But his company frequently contracts to all sorts of different auto manufacturing companies all over here in the U.S. to basically fly time-critical needed parts from suppliers, which are geographically distant, usually Mexico, Canada, or U.S., to the ultimate manufacturing plant. Now, when things go wrong with older style or even modern inventory systems for these manufacturers that feed that just-in-time manufacturing production line, their exposures to cost are immense. So if that plant runs out of on-hand parts, it's literally more cost-effective for the company to pay my son's company $80,000 for a dedicated cargo flight that quite literally sometimes carries nothing more than 10 to 14 car fenders. Okay, it's cheaper to do that than stop the line. So do the math, right? That's over $5,000 per fender. I mean, that's just insane. Now, this example is true, and it has been applicable across all generations of manufacturing automation, as but one example. So the key point here isn't expensive, occasionally, car fenders. It's that the business needs to look at costs and profit at a total system level. So keep that total system level concept in mind as we think about APM business insights. So we fast forward, we call it 3 technology generations. We skip over client server, web, SOA, and now we're at full-on comprehensive microservices-based custom apps. Now, when these are built and delivered with full best practices aligned agile DevOps methods, this offers companies the ability to differentiate on functionality and user experience as well as time to market instead of only cost or brand. So most importantly, these apps can be delivered and developed and made operational orders of magnitude more quickly than previous methods. So the race began across all sorts of different marketing segments and industries. People were basically told, hey, make sure you have an app for that and make it happen ASAP. So this is Insight 1. It's all about getting it built, deployed, and profitable as fast as possible with optimized costs. Because these apps are part of a real-time transaction processing systems deployed in highly scalable and resource, dynamic cloud environments, they do offer the potential ability to reduce cost. No more paying for peak dedicated capacity 24/7, 365. But yes, it was much faster to develop and deploy new apps on target to these dynamically growing markets at exactly the right time. And here's the but. It still comes with a cost. Remember those complexities of monitoring and managing full-stack apps and their associated infrastructure. The reality is if you don't monitor and manage the entirety, you're placing yourself at service risk, and you run the risk of unmanaged cloud infrastructure costs as well, despite the inherent ability of cloud to offer cost-effective computing. So that actually kind of leads us to Insight 2. Faster isn't necessarily better. And I want to talk a little bit about that cost associated with beating the competition to market as digital transformation projects are implemented. Excuse me. Faster wants to be better. Everybody wants just faster to intrinsically be better. Getting to the market ahead of competition with new products, businesses, partnerships, and services is a sure way to capture market share and grow revenues, but it comes with a cost, like I mentioned, and that's the risks associated with those complexities. We've already discussed a little bit ago the complexities of the full-stack application and infrastructure technical environment, but to summarize the complexities and risks, they really fall into 2 basic related risks. One is availability. Will the app and all its infrastructure be available whenever required? And performance. Will the app and all its infrastructure deliver the business required levels of performance measured in the only way that anyone really cares? Response time and throughput. I want it to be snappy, and I want to get it done. DevOps processes and the structures put in place to implement it and support it fit a very rapid deployment of custom apps to the market, just like a custom glove. They were designed to do that. They were designed to prevent surprises by a continuous development and testing model while it was being built. If any change in development didn't work, it was immediately rolled back, re-implemented, and retested in a continuous process. This works extremely well on the dev side, but it can only work on the ops side in ongoing operations if the necessary instrumentation is available for those in-production workloads. The lack of complete coverage in ongoing production will create significant risk to the availability, performance, and capacity costs. So Insight 2 really is you have to have full stack, full life cycle, dev and ops, instrumentation to go at top speed to market and simultaneously ensure availability, performance, and cost-effective delivery. So that's Insight 2. Number 3, customers. Think about it as they're fast to leave when you're slow. Again, in 2020, especially now, nothing can be slow. People don't have any time to waste. There's a lot of things going on online. Infrastructures are being stressed and the like. But while we're on that speed theme, let's talk about the customer-facing side of applications and infrastructure. And again, whether it's B2B or B2C, doesn't really matter. The concepts are applicable to both. So the reality of today's world is that if you can't deliver a timely, highly performant end-user experience to those customers and business partners, they'll go elsewhere. They might do it right away, or they might do it over time, finding, for example, a supplier that is more timely in interaction and delivery. There are dozens and dozens of studies that directly tie bad digital performance and availability to company bottom lines. So everyone probably knows that, okay? But many don't know. In fact, it's actually a bit worse than just that. There's an additional complicating factor. And this was not extremely well known by everybody, but in late 2018, Google made changes to their site ranking, basically for mobile search, to reflect the speed of response. In effect, what this means is that if your custom app website is too slow, your customers might not even find you in the first place. They might not even show up in search results when they're actually looking for a supplier or vendor in a given place. And oh, by the way, it's not limited to how fast your web pages load or whether or not they're available. That's been table stakes for a couple of years now. It's really about the actual performance of each and every transaction. And while you can have super highly performant web pages, if the server side of that app stack isn't performant, you're in effect too slow, too bad. Yet another insight. You have to instrument that full stack in production for all your apps and infrastructure. So let's talk a little bit about instrumentation. What is the instrumentation that is important and needed? So I've long called it the metrics that matter and all the time. We've already talked about why it's important to do it across dev and ops. So Google has something they call the golden signals. Many people have adopted it. These have been known by other names over time, but basically they are now universally accepted as being the most appropriate metrics that matter for today's custom apps and the underlying dynamic cloud service infrastructures supporting them. First and foremost, each metric is individually measurable and has certain obvious characteristics. So for example, if we think about latency, also and for a long time known as response time, basically that's how long it takes something to happen. For example, a new page or a form in a web app transaction or a financial services transfer of funds or ... Use your imagination across the B2B or B2C world. So how quickly something happens, how snappy it is, how responsive it is. Traffic, also long known as throughput, is how much work is actually getting done. For example, how many purchase transactions are being completed per unit time, or how much of a product is being purchased and shipped and delivered from A to B over time, things like that. It's work being done over time as opposed to how quick individual transactions are responding. Errors. Errors. Okay, let's talk about errors. But before we do, let's talk about all the signals together. So latency and traffic are, absent any other factors, the two key metrics that business leaders directly care about. We talked about that earlier. They also care about cost, but it's hard for technology solutions to directly measure cost. How much work's getting done? How quickly are the users happy? But each of those signals has hidden levels of complexity and interrelationships that you need to understand. So while latency has a physics aspect to it, for example, it must absolutely take a certain amount of time, and it can never be any faster due to some physical constraint. For example, this is why for a long time you should locate your database servers close to where the transactions are coming in. Or you locate your cloud data centers as close as possible to the geographies that they're serving so that you don't have latency going across the world. Okay. Or for example, if we think about traffic, it has innate physical constraints. For example, you can't move 100 gigabytes a minute over a network element or segment that's configured for 10 gig. But it's also impacted by errors, saturation, and latency. So there's interrelationships here. So it turns out that all these golden signals, these metrics that matters, are directly impacted by other signals and metrics, and sometimes in complex and counterintuitive ways. Latency and traffic can and should be, and increasingly are, being measured and monitored in today's custom app environment, running on hybrid public cloud microservices environments. But errors and saturation are special. I said a yeah but about them a moment ago. And let's talk a little bit about why errors and saturation are special. Errors are different in that they're not a black and white thing. They're not an up and down thing. There are multiple types of errors, ranging from informative or warning up to critical or catastrophic /down, right? But these errors, in turn, are related to one another in terms of their impact on application performance ultimately. So each of them must be individually and separately tested against that complete app stack and environment so that you understand that total impact. And this drives a need in development and production for comprehensive and centralized log aggregation and management so that you can do that. Now, perhaps the most special of the golden signals is saturation. It's more special because it causes effects that many times are counterintuitive and highly impactful on all the other signals. When shared resources, and this doesn't matter if they're cloud resources or on-prem or hybrid or a mixture, when shared resources reach their intrinsic saturation point in the amount of work they're actually being asked to do. For example, if you reach CPU saturation as but one example, the impact on response time and throughput is not linear. It is not directly predictable. In other words, things like doubling your transactional load doesn't necessarily make the response time twice as long. It might or might not. It depends on saturation. Or it might halve the traffic. Again, saturation. It might. But it might also have minimal effect. Or it might have catastrophic effect. Yeah, you can alert on when you reach a saturation or tipping point per resources that's known to negatively impact a given app and signal. But the saturation points themselves across all the elements are constantly changing. And you've got that resource contention, noisy neighbors to factor in. In many cases, saturation can cause highly nonlinear degradation in throughput and response time. So net on this, there really is only one way to properly manage this complexity, and that is APM, again, on all your apps and infrastructure. Now, the problem was this used to be heinously expensive and not very simple either. And we'll talk a little bit more about that cost angle in just a moment, but keep that in mind. So on to our fifth key insight. Observability. Observability is critical, and that's why I put it last. All stakeholders have to be on the same page. Now, one of the key factors driving the need for this full stack observability is the reality that for the vast majority of companies, all their apps are simply not these new and modern apps, not completely, written from scratch using the latest technologies, latest cloud architectures and infrastructures. Most companies have loads of, I'll use the term, it's not derogatory, but legacy applications that are of critical importance to their bottom lines. They might be monolithic apps, or in many cases, they're tiered or service-oriented client-server applications working with existing legacy databases of record. And they also have the newest of apps written in modern languages using microservices as they roll out digital transformation efforts. So in many cases, the apps themselves are hybrid. So this mixture, coupled with the realities of business criticality, time to market, as well as resource skills, really means that many times only parts of the existing applications are being rewritten to be microservices and cloud-based in order to meet that irresistible time to market demand and capability of companies' digital transformation efforts using custom apps and the cloud. So when you combine this reality with the various, varying, and constantly changing roles and responsibilities across all the teams across that stack I talked about before, in order to ensure appropriate performance, it really demands that everyone involved have a consistent, common, and combined view of those metrics that matter over time across the app and infrastructure stack. So the fifth insight here really is that for observability, only full stack APM offers the ability to deliver on this requirement. All your metrics, all your apps, all your app performance traces, all your infrastructure, and all your logs All of it has to be available in one place so that you can achieve observability. So APM is required. What has held people back in the past? And so there's just a couple analyst takes here I'd like to go over, and then just sort of talk about the generic kind of reality here. Gartner's take is that APM growth is exploding. In 2018, they were talking about it quadrupling by 2021. We're seeing, both talking with customers as well as other research is showing that is further accelerating, and it's accelerating yet again due to COVID. And the incredible adoption of new apps being rolled out. If a brick and mortar company, whether B2B or B2C, didn't have a web presence and a web transactional capability in January this year, you can bet they're working on it literally to save their business lives. So that's driving the growth and need. APM is required. IDC has a similar take. The reality is why didn't companies adopt APM more pervasively earlier? And the reality for that gets back to that comment I made earlier when talking about the heritage of APM. Original APM solutions were designed basically by and for application developers. And so as such, you had to have an intimate knowledge of the application in order to be able to get it instrumented to collect the metrics that you needed to understand the actual performance inside the application. So there was a complexity angle from the start. The other one was that the original APM solutions, and many today, are still incredibly expensive. And so as a result, companies are pretty much deploying them, or to date have only deployed them, on only the most critical of critical applications and infrastructure. So cost and complexity have been the major issues driving or holding back companies' more pervasive, more ubiquitous adoption of APM. Let's do a quick gear change and just talk briefly about the SolarWinds APM Suite, and then we'll get to a demo and your questions as they come in. So the SolarWinds APM Suite is really designed around providing unmatched visibility into your logs, your metrics, your application performance traces, your hosts, and the whole digital user experience. So bringing together that user experience, your metrics that matter, your traces, your logs into a single unified view. It has two major elements with overlapping use cases, but we have what we call client side, which is web application performance monitoring. For that, we have our Pingdom solution. I'll talk about that in a little more detail, but Pingdom is all about uptime, page speed, synthetic transaction performance, and real user monitoring. All from outside the firewall, all from that client side. How is it actually happening in the real world? Again, you can use it in development, and we'll talk about that. Server side, or inside the firewall, or everything downstream of the client side, depending on your deployment model, we have application performance monitoring with AppOptics. So that is comprehensive APM for both infrastructure and application code itself for monitoring, tracing, custom metrics, and the like. And then we have centralized log monitoring and analytics with our Logly solution, which brings together application logs, infrastructure logs, service logs, all into one place and in an integrated workflow fashion so that it can be used to solve those dev and ops use cases I talked about before, speeding MTTR and proactively preventing problems. So that's the SolarWinds APM Suite in a nutshell. Let's drill in a little bit on the client side, and again, we'll be doing a demo on this momentarily. On the client side, it's all about understanding what's going on there. So there are two major buckets of capability. One is around synthetic monitoring. So the concept of knowing the instant that any given website or page is unavailable. Pingdom delivers geographically dispersed monitoring from over 100 different locations so that you can make sure that the user experience is within appropriate parameters globally. It's about helping optimize that user experience with ensuring faster load times of each and every page associated with the business transactions. With page speed monitoring, you can know why it's slow, so you can troubleshoot it faster and continuously deliver that uninterrupted user experience. Find and fix site flow issues before they impact your business, be alerted on them, and the like. And then, especially in production, real user monitoring rears its head as a super important functionality. You really need to understand how your users and their digital behavior is performing and impacting things. Identify those bottlenecks, again, as fast and as quickly as possible. Troubleshoot them, again, from the end user perspective. At the end of the day, if the real user performance isn't good, it doesn't matter how excellent the performance and availability of any of and all of your infrastructure is. It's all about that critical experience of the end user in terms of response time and throughput, those golden signals that we talked about a little bit before. On the server side, it's really about optimizing the performance of the application with metrics, traces, and log management across both the infrastructure and the application elements like services itself. So SolarWinds AppOptics has two major capability buckets. You can use it to monitor and manage the entirety of your infrastructure with server, virtual host, container monitoring with a whole bunch of out-of-the-box integrations, too numerous to go into mention here. It's about avoiding downtime using things like heat maps and container maps and getting proactive notifications when resources are violating thresholds before they go critical, before you reach saturation and you get those nonlinear impacts that I mentioned before. And it's about monitoring both legacy and new IT implementation, detail host views, click drill downs into resource utilization, whether it be by services, containers, hosts, processes, or the like. On the application side, AppOptics offers powerful visualization capabilities with service maps, which can visualize the relationship between and across the services and their dependent other services across your environment, again, in the context of the application and its performance. It's got very simple root cause identification so that you don't actually have to be an expert in how the application was written to understand what the actual root cause of a performance bottleneck would be without necessarily having to drill down. Yes, you can drill down and get as fine and granular as you want, but we've simplified that to make the adoption of APM easier and faster. And of course, it delivers transaction and code level troubleshooting with distributed tracing, live code profiling, and exception tracking. And again, we'll show you all this in the demos in a moment here. So that's SolarWinds AppOptics. SolarWinds Loggly is used really in two major elements, again, as I mentioned before, both in dev and in operational production environments. It's got capabilities on the infrastructure side, basically any and all infrastructure logs that you can think of from virtually every source imaginable, cloud platforms or services, Amazon, Heroku, etc. Infrastructure host operating systems, and again, these could be deployed on-prem. They don't have to be in the cloud, but things like Windows, Linux, Unix, Mac OS, web servers, endpoints, Linux and Windows file monitoring, Docker and Kubernetes, automation and provisioning tools, as well as numerous other sources of logs. We have a saying we've long used: if it logs, it can log to Loggly. But basically, get all your infrastructure logs in one place where you can gain insights across them in the context of the application. Speaking of the application and database management logs and service logs in Loggly as well. There's broad support for all the languages, as you would expect. There's database support for SQL Server, Mongo, MySQL, Postgres. And then there's additional services and components. You can do things like tracking pixel logs, webhooks, gaming development platforms like Unity 3D, and there's a lot more. We've got comprehensive lists on our website. But basically, if it can log to Loggly, and Loggly is a key element of our APM suite. So with that, what I'd like to do is turn it over to Pete DiStefano for a demonstration here very quickly. So Pete, I'm passing the ball to you.
Awesome. Right. All right. Dave, can you guys see the hotel application?
Yes, sir.
Okay, great. Well, I'm going to take about 10 minutes or so to kind of maybe punctuate some things that Dave talked about, and I'm going to kind of do a quick high-level demonstration of our APM products. And as Dave mentioned, with regard to the business insights, how fast you can identify when there's a problem, how can you simplify what is a very complex environment, getting more complex every day? As Dave just mentioned a moment ago, whether your application is in a cloud, whether your application is on-prem, what if you have a hybrid where your application is spread and the services are spread between on-prem, maybe even multiple different cloud locations? that complexity makes it more difficult to figure out what's going on and where there's a problem. And that, again, another big reason to have these APM tools. So for those of you familiar with SolarWinds, we have a fairly large portfolio of products to help IT professionals manage IT from a variety of perspectives. What we are showing you today, the three products I'm going to go over, the three products Dave's talked about, are SaaS-oriented products, but they can manage on-prem as well as the cloud. What you see here, just so you know, this is our demo site. This is a hotel booking application. And when you talk about how important it is, especially with customer-facing online applications, if I have a tough time, if this takes me forever, it's not working correctly, guess what? I'll go and search another site because there's a whole lot of other places I can go to book a hotel. So that whole idea on the Business Insight is when it's slow, the user says, enough with this, I'll bounce because there's probably an alternative. So we're going to talk about all those business insights and how you can leverage the APM products. I'm going to start by just giving you an idea of the three products. What you see here is the home screen for SolarWinds AppOptics. This is the home screen for Loggly, and this is for Pingdom. Now, these are three different products, but they continue to come closer and closer together. As you can already see, the approach to engage is already similar. If you have any one of these products and you add a second, you add a third, you only need one ID, one password, and you can bounce in between the products. And I'm going to show you even some of the other integrations that have been built in. But let's start here with AppOptics now. So with AppOptics, what you see here is you've got your services, which are listed. It's a handful of the services, and you can go to all the details. These are like your application services. Then you've got your infrastructure. So SolarWinds AppOptics does both infrastructure and application monitoring. This showing you the plugins. And basically, when you install a plugin, you install an integration, what comes right out of the box is a bunch of dashboards. So I just want to show you this real quick. I'm not going to go into this in a lot of detail, but as you can see here, as you just install one of our plugins, we automatically come across with pre-populated dashboards. So here, this is an example of a Kubernetes dashboard. Didn't have to do a thing. This comes straight out of the box. What I'm going to do, though, is I'm going to drill into the infrastructure. So what I did was on this icon for infrastructure, I can look at the infrastructure from a map perspective of a list. And in this case, you're looking at a list of the containers. I can look at it from a container perspective if you are implementing containers. And what this does is this gives me a real-time status with color coding of 102 containers. This could be 102, this could be 1,000 containers. I can filter it, I can group it, and you can see I've got different color coding where they've exceeded thresholds. Very easy to do. I can also just look at my containers from a list perspective, or like I said, I can look at my hosts. So what I'm going to do here now is I'm going to drill into one of my hosts, and it gives me information about how that host, whether it's physical or virtual, is performing, CPU, memory, disk, but it also tells me what are the services that are running on that host and how are they performing. And I can go even deeper to looking at what are the processes that are running on that host. So I can drill down, and by the way, I can very easily, from any one of these drill downs, create dashboards and create a brand new dashboard. Very simple to do. So now I'm going to click now here on this APM, which is where we get to the application side. I showed you that hotel application. This is showing you an example of all of the microservices-based elements that make up that hotel booking site. From the front-end web tier to the authentication, to the pricing service, the search service, the booking service. These services are what makes up my application. So right out of the chute, from this list perspective, again, I've got some information. I'm going to click over here. This is something fairly new to AppOptics, where we've now included a service application app. And you can see here, you've got these are green. I've got these, couple of these are red. That's because there's an issue with those ones in red. This not only shows all those services like we saw on the list, but this now shows the relationship between the services. It shows the dependencies on database, cache, other domains. So there's a lot of information I can get from this visual representation. Then I can click into the booking service, and then I start to see some information here like we were talking about earlier, response time, request error rates. What I want to show now is when I clicked in to that web tier, I get this thing called a service level summary. So what it does is, if you're not intimate with the application, you're not a developer, right out of the chute, this is telling me, hey, here's how this service is performing. It's telling me, hey, most of the time is being spent with calls to the booking service. And then it's giving me something loosely related to the four golden signals. You've got your latency or your average response time. You've got your throughput or request rate. Of course, you've got your error rate. And then with saturation, in this case, it's showing CPU. And this is comparing it to a week ago. So I can just look at these charts real quickly and say, hey, do I have an anomaly here, or is this something that happens all the time? And again, I can change it to the last 24 hours. I can change it. I can look at it from over a month's period of time. So this one specific summary screen gives me a lot of information, and I don't have to be an expert when it comes to the application. Now, if I want to go to another level, I click on the detail screen for the service. It's got some similar information, but now I also have information about what types of HTTP codes was I getting? What were the HTTP methods being used? What were some of the top transactions, the top hosts supporting those services? So again, now I'm drilling a little deeper. Next, I want to go further into the detailed traces of the transaction. Dave talked about the capability to continue to drill down in App Optics all the way to code. So here's an example where I clicked on, and there's thousands of these transactions, and what I've got here is like a heat map, and I'm looking at it over a period of time. I have the last 24 hours. I can change that, and what I can do is I put a box around an outlier, and when I click on it, it's going to give me another summary. Here's an example of that outlier, and it's telling me right off the bat, 97% of that request, that 2 seconds, 97% of it came from the database call. And then below, it shows me those queries and how much time they spent. And you can see here, you've got these queries that were taking 918 milliseconds, almost 800 milliseconds, but there was 29 calls to make that happen. So it tells you right off the bat what's going on. Okay, and from here, said, that's not good enough. I want to drill deeper into the details. But this is the kind of screen, even someone in operations can say, hey, I screenshot this, I go in and put a ticket in, I can report this to the database folks saying, hey, this is something we really probably should be looking. When I click on the details, I now get what we call a trace waterfall. It literally breaks down that transaction for each layer, okay, and then the spans within each layer. So as you can see here, it tells me of this transaction that took 3 seconds, of this transaction that takes 3 seconds, you can see here at the bottom, 2.91 seconds was in the database, right? Now, the other thing I can do here is I can drill into any one of these layers, and this is where you talk about going beyond. So we can go deeper into the database. It's showing me queries here, but I'm going to click on the Java layer, okay? And then I'm going to say, okay, well, wow, this one took 2 seconds. I'm going to click on this specific Java request, and I get a lot of raw data about that Java service. I click here on Code Profile. This is now telling me the lines of code where predominantly the time has been spent for that part of the transaction. So this gives me the chance to drill deeper and deeper in the transaction to really get down to what's going on. If I need to get to that level, I can go all the way down to the code. Now, something that I wanted to share with you as well is I'm on this distributed trace. We've been drilling down here. Dave talked a lot about log management and Logly. And a lot of people call event logs is like the evidence. It's the forensic analysis that gives you the proof, right? So again, to keep things simple, when you think about these business insights, how quickly can I get to the end result? And in a very complex environment, how can I simplify the process? Well, here you see here the search logs. I'm going to click down into that search logs. It's going to go right into Logly. And what it's doing, it's embedding that trace ID into that search. So now what I've done is every log line associated with that transaction that we were just looking at is grouped. So I don't have to do any additional searching. I can see every single one of these log lines that was associated with that transaction. And this is very powerful because a lot of times, if you were searching, say you were just using a log product standalone, you were searching, how do you get all of those IDs together? Because these happen at different times. So you start to search before and after. Here, one click, and I'm looking at all of those searches together. To further talk about Loggly, what I'm going to show you now is an example of the powerful analytics and dashboarding that comes out of the box with Loggly. This is just a couple of examples of some Linux dashboards in Loggly that you can modify. You can create your own dashboards within Loggly as well. But let's go back to what I think the most important part of log management is, and that's being able to quickly identify the log line that's going to clue me in on what's going on. Okay, so one of the most powerful parts of Loggly is its capability to automatically index and parse all of the logs it's ingesting. So you very quickly can get to the end game. You could, with a lot of other approaches, you can click on search and it'll take forever. In this case, because we have something called the Dynamic Field Explorer, if you see here on the left, I've got some Java errors I want to dig into. Well, I'm going to click here on Java, and I'm on look for errors of Java exceptions, and there's a specific one here I'm going to click on, and then just like that, a couple of clicks, and now all of these specific Java exceptions that I have, regardless of when they happen, they're all sitting here right in front of me, so I can do additional problem determination. So from the capability to do some analytics, but really the power of log management is being able to quickly do the searches. And then when you look at the integration I just showed you between AppOptics, where you have one click into those associated logs, again, collectively very powerful. I want to talk a little bit now about the client side. So what we've been talking about so far has been the server side. Dave talked a lot about it, digging into the server or the server, the database, the infrastructure, all of those elements that make up an application, but you can't ignore the user's experience. You might have in your operations environment, everything looks like it's green line. Everything's up and running, but if the user is not happy, if the user's perception or reality is they're not getting the performance they expect or access they expect, that's a problem. So you do need to combine both. So really quickly, as Dave said, Pingdom is really broken into two things. You've got synthetics, where you simulate tests to see if things are up, to see how pages are performing, to simulate transactions like booking a hotel, as an example. And then you've got the real user monitoring, the actual user experience. You combine those two together, you get a real good perspective of how the user is experiencing your application. So I'm just going to quickly pop into a couple of these things. Here's an example of just looking at uptime. Okay, so I've got this hotel in Asia Pac. How is that service doing? Is it running? I could run these tests every 30 seconds to see, is my application up or not? And if it's not, I can very quickly get an alert through any type of notification like Slack or PagerDuty. Of course, I get these events here inside Pingdom, but it's really about sending an alert and firing it off through your notification system. Pingdom does that in spades. So now I'm saying, okay, but what about the page performance for when the folks in Australia are trying to sign up for a hotel? Well, with the page performance, again, synthetic monitoring, it gives you an opportunity to test the performance, and literally you can drill down into every element that loads a web page and see where the latency is and which element. Maybe I've got a really big image that wasn't optimized, or I've got some really bad JavaScript. So it tells me, it breaks it down in detail exactly what is making up. And this is not a great example, but you actually have a visual film strip that shows you what the web page looks like as you're progressing. Again, it goes deeper and deeper into the detailed performance of that page loading. This to me is really important. Now we're looking at, in Australia, we talked about page performance, looked at it up and down. Well, I want to make sure my most critical transactions are performing, right? So for example, I'm going to click here. This is a transaction, a simple transaction that was created to make sure that I can sign in to sign up for a hotel. So I'm just going to click here and show you. We can decide where we want to run this test from, and this is a very simple test. From going to the website, putting in the email and password. You could see here there's several steps, and these all came back green because everything's up and running. This could be 50 steps, right? And with Pingdom, we've recently added a recorder that makes it so simple to create a transaction. You literally hit the start button, and you literally emulate signing up for a hotel or buying a product or looking up something, and then you hit stop, and it creates that recording, and then that builds the transaction for you. So it's very easy to test to see whether or not a transaction is functioning. It's also great to do this in a down environment because, in a development environment, because after you think you've fixed the bug, you can run a transaction test to make sure it works from the user's perspective. Last thing real quickly, now I want to talk about how are my users experiencing, logging in to sign up for hotels. So I'm assuming a lot of these folks are in Australia, but I could look at the experience that those users are having all over the world. So here I'm going to just drill in on Australia alone, and it's going to tell me about how many sessions. It's going to tell me what the customer satisfaction score is. What were the top pages? It's a little boring just looking at Australia here with my example, but I think you get the point. And I can look at this based on what platform, my desktop, tablet, what browser were they using, Chrome, Firefox. And then again, what I was showing, I can do it by region. In this case, I can look at all countries. So between the client side, Synthetics and Real User Monitoring Pingdom, together with the server side, and by the way, just to show you an example, this is an AppOptics dashboard that is showing Pingdom information. So the capability to connect the dots between all of these products is very powerful. So I know we're just about out of time. I'm going to pass this back to Dave. Just wanted to give you guys a real quick snippet into, quite frankly, the simplicity that these products have built in, yet the power and where they can get you to without a whole lot of strokes. All right, Dave, I'm passing it back to you.
Okay, can you hear me?
Yes.
Okay, thank you very much. So we'll answer the questions. There are several come in, and we'll go through those. But while we're answering the questions, if you could, if you will, please just take this very short survey. It'll be up for 3 or 4 minutes here while we go through the questions. I would appreciate it. You should see it on your bottom right. Pete, while you were demoing AppOptics, a question came in. Can you do JVM monitoring on the applications server/container side?
Yes, absolutely.
Yeah, it's literally out of the box. Another question came in. How does AppOptics compare to other APM tools like AppDynamics or Dynatrace?
Okay. By the way, Dynatrace and AppDynamics are both very formidable tools, no question about it. But so is AppOptics. Depending on what you're doing, and by the way, there's some materials we can share with you. AppOptics is very competitive, and when you look at, depending on the environment you're talking about monitoring, whether it's cloud or on-prem, whether it's Java, whether it's PHP, Python, AppOptics stands up very strong against those products, whether it be infrastructure, application, the distributed tracing, code profiling, and then when you combine the end user monitoring with Pingdom and the log management, it's very, very, very competitive. And then I'll leave you with one other point. If cost is an issue, then you really need to be looking at AppOptics. I can't tell you how many times that has been one of the major reasons that companies have come to us with some of these other products installed. But the first thing you need to do is make sure it meets your requirements. And I think you'll find more times than not, it will more than meet your requirements at a significantly lower cost to you and fairly simple implementation. You kind of got an idea from the demo of how easy it is to show the product. It's pretty much that simple. There's a lot of auto instrumentation, so very easy to use as well.
Excellent. Thanks, Pete. Another question came in. I'll answer this one. It asks, will the presentation be available later? I wish my boss heard some of this stuff. And so, yeah, we will send that out a recording of this afterwards. So that's no problem there. I'll add some additional color, Pete, on your response to the app dynamics and Dynatrace. And this is true across the board. SolarWinds has a rich heritage of designing powerful, simple to use, and highly affordable solution for IT professionals. And we're taking that exact same approach to the APM market, if you will. A lot of people have not yet heard of us in the APM market, but we have very powerful capabilities at a highly affordable price across the portfolio. So it's not limited to just AppOptics. It's also Loggly and Pingdom, both of which are also highly affordable. So let's see if we got any other questions that have come in. It looks like we do not. That's, I guess, a good thing because we're at the top of the hour. I want to thank everybody for participating. Thank you for answering our survey. At any time, if you want to reach out to us, feel free to do so. You can reach me at david.wagner@solarwinds.com, and you can reach Pete at peter.distefano@solarwinds.com. With that, thank you very much for attending. We hope you found it of interest, and have a wonderful remainder of your day. Thank you.